Students, please get out your entry problems. Please pause the recording so you can work on the entry problems. When students are done, Miss Seidler, if you wouldn't mind calling on students to present their solutions. And after that, we'll go over questions on homework problems if they have any. Students, after you go over homework questions, if you could put your assignment in the yellow folder. So again, first we'll do the entry problem, pause the recording, and then after the entry problem, we'll go over to homework questions. After the homework questions, you guys can handle your assignment into the yellow folder, and then we'll go to notes. So please pause the recording at this point. Now, if there are any homework questions, this is the time to get those answered. Please pause the recording if there are any homework questions. And now we're going to get started on today's lesson. So today we're going to be discussing inequalities. So inequalities, first thing I'd like to do is review the symbols for inequalities. We have less than or equal to, greater than, or greater than or equal to. And the way we differentiate less than or equal to and versus just less than is with the line under it. The less than symbol looks a little like an L, so some people remember it that way, like a capital L a little bit. Greater than goes the other way. So those are our symbols. And today we're going to talk about graphing inequalities and using interval notation. And we learned about interval notation back when we did our first chapter. So if we were to write inequality statements for the following, I could say A is less than B because A is -8 and B is -2, which is less than C. So this is called a compound inequality because A is less than B is less than C. What's also true is A is less than C, B is less than C. You could write C is greater than A. That is not a C. Let's redo that. Whoa. Sorry. C. Wow. Weird. C is greater than A. B is also greater than A. You can write just a ton of these. And it just is a comment on the relationship between A, B, and C on the number line. So, is this a correct statement? Is 3 less than 9? Well, it is, yes. And one way you can consider this is that if we take a look at a number line, here is 3. So 3 would be right here. 5, 7, and then 9. And so this is true because if we graphed each of these, here's our 3 and here's our 9. Less than, in terms of our number line, means that 3 is to the left of 9 on our number line. So 3 is less than 9. Now, if we wanted to graph this solution set, x is greater than or equal to 4, we're going to shade all of the quantities where x is greater than or equal to 4. So what we learned in chapter 1 is that for greater than or less than, we use the parentheses. And for less than or equal to or greater than or equal to, we use our brackets. Okay, so this is a main idea that we want to remember, is when to use the brackets and when to use the parentheses. So if I were to graph this, that would look like that. So on 4, I would put a bracket because it's greater than or equal to, and then I would shade to the right because these represent the numbers larger than 4, because x is greater than or equal to 4. So you're shading numbers greater than or equal to 4. Another trick I learned is that the little arrow is pointing, in that direction, and so you point in that direction for your shading as well. So there's our solution set. And then if we wanted to give the interval notation, we learned how to do that as well in chapter 1. The interval notation describes left to right the values for which x could be. And when we state the interval notation, we do a parenthesis or a bracket depending on what it is we are graphing. And it is lower bound minus the upper bound. And then you end it with a bracket or a parentheses. So it's lower minus upper bound, like that. And so in this case, if you read the graph left to right, it starts at a 4, and we have a bracket, and then it goes to positive infinity. So that would be our interval notation. 4 is our lower bound, and our upper bound is infinity, because this is an unbounded interval. Just keeps going and going. And then because you can never reach infinity, by the infinity, you always use the parentheses. So if we were to graph the solution set to x is less than or equal to 9, I would go to 9. And because it's less than and not less than or equal to, I would use the parentheses. Less than, I'm shading everything less than 9. So I'm going to go less than. Okay, and that is my graph. X values less than or equal to 9. And again, if I consider this like a little arrow, it points in the direction in which case I want to shade. Now for the interval notation, I'm going to read left to right. So this left side, this is negative infinity over here. So by negative infinity, I have a parenthesis. And by positive infinity, I have a parenthesis. So it's negative infinity to 9. And then by the 9, I have a parenthesis because it does not equal 9. It's just x is less than 9, not x is less than or equal to 9. So that is my interval notation. Here, this is a bounded inequality because you have a lower bound and an upper bound. So the lower bound is 4, and it can equal 4. So by the 4, I put a bracket. It cannot equal 9. And so by the 9, I'm going to put a parenthesis. And then I'm going to shade in between to indicate that it's all values, including 4 and up until but not equal to 9. And now when I state my interval notation, when it's a bounded interval, all of the symbols are there. So it starts with a bracket, just like what's on my graph. And 4 is the lower bound, 9 is the upper bound, and it cannot equal 9, so I have the parenthesis there. So your assignment for this one is in your textbook, 17 through 33 odds, 43, 45, and then 71 through 83 odds. Please be sure to graph if they tell you to graph, so pay special attention.